Hey, good morning, good evening, folks.
Hey Dan,
Hey, thanks for the mic check. Actually, what time is it for you, Anish?
9:30 morning.
9:30. Okay, good deal. Um, we'll see if Alexi joins. Um, I pushed the I pushed the base series to Linux Next. So far, no issues. Um, I got a couple comments on that finalized series, but I'm not seeing much more. So I was thinking about just updating updating for those review comments tomorrow, and then also pushing that to Linux Next. Um, and then uh, so I understand that, like I saw something from Suzuki about, hey, that maybe the CCA spec is going through a revision that
Yeah,
do,
so we can
does
actually
that
definitely
does it
have this
impact?
thing in your staging.
Okay, okay,
So I think that would be good to kind of get whatever I have done in your staging, so I can create a TSM staging.
okay.
But as such, merging upstream, we may want to kind of get to a spec that is stable enough, and then
Mhm.
at least one round of revision on the spec side, so that I can be sure that if we try, we don't do real big breakage, right? I mean, so I'm not even advising for Linux Next for these changes, but then your staging is okay because we can compare different implementations, right?
Right, right. Okay. Yeah. So the thing I'm looking for is for the core pieces is have at least one vendor implementing it.
Yeah, I
So
already
it sounds
have
like
the IDE setup done. I can push straight away, and then we can you can probably, but then I think you will be redoing the branches, right? Staging every time. It's not like you don't expect even the staging tree branch that I'm pushing to remain stable. It can be rebased and things like that.
it can be rebased.
Yeah,
Yeah.
yeah.
Yeah, I mean, for staging, I have no concerns. I'll whenever you tell me you have a branch, I'll
Mm,
just include
mm.
it, and off we go. Yeah, it's just a matter of there might be a lag, because if I rebase, I'm not gonna I'll be like, hey, tell me when you rebase, and then I'll pull it in. I think it'd be nice maybe to get into like a cadence of maybe like every other week, like
Yeah, makes
base
sense.
tree
Sounds good. Yeah,
base
sounds good.
base tree
Yeah, yeah,
changes, then
yeah,
then vendor trees changes, then base tree changes, kind of thing.
yeah.
So we could try to do it like that. And we'll have the tags too, like the stable tags. So probably people that are trying to play with this stuff will be like a week behind.
Hmm.
But we could do something like that. But in terms of merging the base stuff into 619, I wanted to go with at least one vendor. So it sounds like ARM needs another cycle
Yeah, definitely.
to do
Yeah.
that. I think TDX needs another cycle, if only because we are dependent on this rework of how VMX on is managed. And Sean took that, but then Sean also got he's been doing a lot of other useful cleanup work, but I think he kind of put the VMX on series on the side. So I don't want to poke him too much. I want him to get whatever he's getting done, and we'll probably have to put the TDX. That might, but that puts for me. I think that puts the TDX series. It puts the TDX series at risk for 619, unless VMX on gets into the KVM tree into KVM next within the next couple of weeks. So I think that leaves just Alexi, and I'm not aware. I was hoping he'd be here, but I'm not aware of Alexi having anything that stops him from going for 619. He said to rebase on the latest stuff, but yeah, I think it's looking like AMD is probably going to be first, which is okay. And then everybody else will be in staging um, coming up. Okay, I see some new faces joining. I think everybody might know each other, but maybe I'll do some let people introduce themselves if they haven't joined this meeting recently. I think everybody knows Steve runs the morning session of this on everything else. But anything else you wanted to say, Steve? You just pop it
Yeah,
in.
so the thing I want to say is I'm interested in starting to play with this a little bit more and trying to
Mhm.
actually get this working on our side. And I was curious to just kind of rubberneck, see where you all are, find out
Okay.
what actually might be possible at this point, and
Okay.
where I could pick things up. Also, where things were in terms of testing with either
Mhm.
QEMU or these types of things to start getting people in Google
Playing with the stuff.
prepped to play with the stuff.
Okay. Okay. I will. I'll finish letting people do intros, and but I'll show you a document I put together that because I need it's for my own sanity, but I think it might help other people figure out like what is in this tree at any given point in time.
Is this the
So I'll
maturity map? Because that was a super useful thing. I don't know if there's more than that thing, but
just yeah
anyway, I'll let you keep going.
just a maturity map. But yeah, I'll walk through that for other people too. But yeah, that's
That's
exactly
cool.
it. You're right. You already found it. Good. um, hey Rob.
Hey Dan, hey everyone.
Hey, how's it going? So, I, have you met everybody on the call here before?
I
Or
know Anish and I think Steve, we've been on a couple calls, but don't know David or Elon.
okay. And well, maybe you do your intro and then I'll ask David
Yeah,
and we'll.
so I'm Rob Dertney, software architect at NVIDIA. So watching over the CC and secure AI solutions over here.
Okay. And then David, do you want to just give a quick rundown for Rob? You guys haven't met him
Sure.
before.
Yeah, it's fine. So I'm Dave Quigley. I work on confidential compute over at Intel on a various number of products that I don't know what's been announced or not, so I don't use names. But
Yeah. This is
yeah,
open source recorded call. Yeah, so nothing. This is all
yeah.
open source.
So I work on software architecture and GPU architecture for confidential compute.
And Yilun.
Yeah. I'm Elon from Intel, and I'm responsible for the TDX Connect implementations and to support the overall TSM framework and confidential computing. Yeah.
Cool, thanks. And then Vivek.
Hey guys, this is Vivek Balasubramanian. I work at Intel with David and Dan also, software architect on the TDX Connect side on the GPU team. Nice meeting you all.
Cool. So yeah. So uh, where we were. I so I think you know. So we're talking about staging for 619. Yeah, I think we have a plan there. But other than that, before I start going to this maturity map, just to ramp people up on what this document is and what it has. Actually, I think I tried it last time too, but maybe I'll do it again. And but any other opens that people want to talk about
Yeah, so
today?
the one sticking point for me right now is the guest request. I think we are having different idea about what it is and what it should be. Uh,
Okay.
One of the big confusion, I mean, I have been looking at Alexis patches, and so the challenge where I came into is if so the guest request interfaces on ARM takes a lot of different structs, as in like if it is like a request info kind of a thing, there is a sub request within that which is specific to ARM. And so we kind of look into that and then say, okay, this is a request for measurement blocks, or this is a request for certificate chain and things like that. Now, so the challenge, one of the thing that I was struggling with was this thing is kind of on ARM. This thing is kind of built by VMM. So basically, the guest will make the request, and it will exit all the way into VMM. So the guest request would be like, get me the certificate, and then VMM will build a structure and then use that as a payload to guest request. So guest request ends up being this large multiplexer, but then the structs is should be in UAPI in the kernel, right? So that's where I got really uncomfortable regarding, do we really want the sub request of guest requests to be UAPI? They being UAPI implies they need to be separate IOCTLs, right? I mean, and the TSM ops. Is that supposed to be a transparent payload where host doesn't interpret at all, and hence there is no UAPI? The VMM just takes the blob and pass it through. I think that's what AMD is doing, but on ARM side, uh, I am using it as kind of like a giant multiplexer.
Are you saying that that on the AMD side, it basically goes out to, like, the multiplexing is kind of handled at the ends, or in their PSP firmware,
Correct.
and you're saying
That's what I
on the ARM
actually
side, you want to do
understand.
some you want to do some parsing, and then
Yes, I end up parsing
public.
because there is no kind of like blob as such. So we get a request from guest. Host can look at the request. Sometimes the request would be like a complex one, which needs to be split into multiple firmware operations. So they end up being multiple guest request calls for that one request that the guest has done. That's even possible that we end up doing multiple calls.
How about that we just use the guest request to pass the guest request content to the TSM driver, and the ARM TSM driver could choose to use different firmware calls to
Yeah, that's exactly what I'm doing. So
yeah.
So when we say ARM TSM driver needs to do, so it's the guest request callback of the TSM ops. The challenge is the sub request format, as in the structure which I use for identifying the sub request. That's an UAPI now because VMM is building that. Did that make sense?
Oh, you need a new user space ABI for
each request, because VMM is issuing that IOCTL via guest request IOCTL, right? VMM is issuing that sub request via guest request IOCTL. Did I make sense?
I think so.
Yeah, I mean, I can actually, but I was not able to post this because, as I said, no, there is a spec update. I'm actually waiting for the firmware to kind of be ready so that I can test and post. But I somehow feel that we are looking at this from different point of view, and I wanted to get the feedback so that I can rework it. Right.
Yeah, because the idea is supposed to be that the request is coming out of the guest in a format that basically just needs to be,
which is not true, which is transparent and passed into the firmware, right? That's not true. That's
not
the
true.
thing. Yeah, that's the thing.
And Yulun, it's the same on, or it's ours is also transparently passed through, right?
No, we also not transparent. No, what I am doing is that we actually there is a unified format, that is the GHCI that guest compose this format and pass to VMM, and QEMU actually need to parse this blob to see what are the subcommands are, and the QEMU sorts out the bind and unbind requests, makes them as a separate dedicated IO controls, and for other requests we just pass the blob to the TDX firmware. Yeah.
Everything is same on until the last part. And in case of ARM, even for the other request, I end up looking at the incoming,
Yeah.
the guest
Yeah,
request.
but I mean that if for TDX Connect, we also doesn't pass the guest request blob directly to firmware. We in the TSM driver, we also pass the blob and use different firmware cores to do
Correct.
the
So you learn
spacings.
in that case, those guest record IOCTL subcommand, you need them to be a new API, right? For that VMM, because the kernel implementation that's actually going to issue the firmware calls have a defined structure which need to be shared with the VMM so that the VMM can issue the IOCTL correctly, which makes it a UAPI, right? So you are also kind of using it as a multiplexer IOCTL, right?
I see. And the guest and the host TSM driver both need to understand the format of the blob. But
The VMM doesn't need to.
They
like the QEMU.
the general VMM doesn't need to know the specific format of the blob, but the TDX TSM driver need to know the format.
Mm-hmm.
Yeah.
Yeah. Why does it need to?
So in our case, it's not like a generic VMexit, as in like what is the GHC, right? Whatever is the calling mechanism, which is kind of like a very kind of generic calling mechanism. We have specific functions called as realm host interface, right? So there is something like realm host interface for RHIs for let us say getting the measurement blocks, right? Updating the devices. So the RHIs would come in, and then we will take an exit all the way to VMM, and then I build a format which kind of indicate whether I can make it as a complete binary blob pass through. Yep, I think the I think bind unbind is where I have multiple requests where I ask them to create an object and then log the object. Maybe I can look at making it transparent in the form that for the rest of the request, I take the RHI as such and then pass it down to the firmware. So maybe is there a Git repo where I can see the Intel implementation, Yulun, like which you will be able to share a patch or something like that? I can push what I have so that we can cross check and kind of agree that this is okay.
We had we pushed the phase 1.
Yeah, but that's only IDE, right?
Yes, only IDE. Yeah, let's. I think we can. Let's share. See if we can find that patch. Like at least just the multiplexing, just to see if we're on the same page. But like, I guess what are you asking for? Are you just trying to confirm like, hey, I'm building this big multiplexer. Is that intended? Or are you saying like I
Yes,
would like
exactly.
to?
I don't want to be like, towards the end, this is not what we are supposed to use guest requests, right? I mean, I somehow have the feeling that we don't intend to use it this way because generally there is this idea that, oh, we should not use IOCTLs to multiplex too many things. We should be independent IOCTLs or independent callbacks, right?
Yes. But yeah, I'm just trying to figure out where to stash that demultiplexing, that AMD stashing in their firmware, because we do expect that in the user space VMM that it might understand things about the blob, that the kernel like I think it's okay for the core kernel to not care about it. I think it's okay for user space to care about it, and I think it's okay for the TSM driver to
Okay.
demultiplex, because
Okay.
we already have a pile of already have a pile of vendor-specific ioctls for like setup and that.
Okay. So what we are essentially
so-
saying, it doesn't have to be separate callbacks. It can be one guest request callbacks, and it can handle, which is what exactly I have currently.
Okay. Yeah, I don't quite see a way around that unless we are agreeing on how we break up these requests, like our info formats and but it just feels like that we're building common abstraction for things that everybody just architected way differently.
Okay.
And
Okay.
and yeah, and guest requests will be like the messiest part of this. I mean, my main thing is is making sure that upstream understands that guest request is this kind of wide open multiplexing, um, almost do anything you want and get away with it communication path that the kernel just has to pass through, and that our only pushback, our only way to make sure that people aren't doing strange things is basically to say like you have to assert that this architecture is not violating kernel security model or kernel integrity, and yeah, and just like firmware control, we have to take the vendor's word for it and try to be transparent about that. But I haven't seen anybody react about that piece of it and try to make it prominent in the change logs. But yeah, I kind of think that, but I think it's also another function of the staging tree. Is it and you said, hey, I don't want to get to the end and find out I got to refactor this. The other side of me is like, we might get to the end and find out we need to refactor this. Because in my head, I'm thinking there might be ways to break this up and make it more formal and maybe add ops, but I don't think we're there yet.
Okay, got that.
But yeah, at least nobody on this call will call you on and be like, "Oh, like it, look, yay, we don't like your big multiplexer. Change it." I think
Sure.
I think at least we all know it's coming. But yeah. So if folks weren't here last time, I did open up this maturity map document, and actually people can see that it's moved since last time. Let me see. Okay. Just going to bring up the diff here so people can also see that. Okay. Sharing button. Make sure sharing right thing. Okay. Okay, so to keep my own self safe and so people can follow along at home, I put up this maturity map. This is something I stole from what we're doing on the CXL side, which is basically like, hey, when things are changing, and people are looking at a tree or trying to figure out like what do I work on next or what's missing, what's there, give out this maturity map that kind of just scores everything. And so it's not a forecast, it's not a plan, it is a snapshot of the truth at any given point in time. So the state of the staging branch, what's in, what's out. And higher scores, 3 is a max, is in Linux Next. It still may not even make it still may not make the next kernel. That's like nothing's done until it ships. But in terms of have major combat operations stopped on the vendor consensus, and is it at a point where we are we are in the speak now forever hold your peace phase? That's 3. two is right before that. We're getting stuff. Uh, we have consensus on it. There might be some cleanups in it, but it's in the staging tree. People can play with it. One is brand new things that that we haven't settled ourselves, or we still have major things to deal with other subsystems. Like I feel like this is going to be a big. We're going to be in this phase for a lot of this kind of phase 3 work where we're doing VFIO, IOMMUFD wrangling and DMA buff wrangling with folks. So that I expect that state to be there for that. 0 is we know about it, haven't done anything about it, and X I don't think we have any X's, but X is things that are just topics people ask about, but are out of scope, or we're not doing them yet. And so phase breakdowns are 1, 2, 3, 4. 1 is IDE, 2 is the guest side, 3 is the complex side of the back on the host side. All that DMA buff VFIO fighting that is to come, and then phase 4 is all the attestation stuff. And Peter Gonda was on last week, and he was, or last time, and saying he might be able to take a look at some of this attestation that we're kind of punting. Everybody, like all the vendor TSM driver implementations are kind of punting on because it's not in the critical path yet. But the way I'm using this or other people can use it is I just do a range diff on the tags, on these tags that are in the tsm.get tree, and then look at this file, and you see, oh look, something's moved. Like, so we got the TSM and the IDE core are now went from 2 to 3 because we pushed those to Linux Next. I will say that this will add topics. Scores can go backwards. So at any point in time, if you see new things coming in or you see things going backwards, like that is an indication of we found something new. This effort uncover something, or something we thought something within Linux Next, and then somebody else saw something and said, I don't like that. We need to take it back out. I can bump it back down to a 2, that kind of thing. But at any given point in time, you should be able to try to get a snapshot in there. The big next milestone is making this ARC support field not none, and that will be merging in. Hopefully by next time we have ARM, AMD, Intel, all represented in phase 1 in the staging tree. In terms, so Steve, you asked specifically about testing. At least for it's not super interesting, but it's interesting to me. A lot of the ABI tests, like, is SysFS actually operational, working? Have we tickled all the ABIs, at least on that side? That's kind of what the sample driver is for. I'm continuing to build that out as time goes on to just cut out a lot of the complexity, not have a real device, but just actually make sure the ABIs are functional before real devices come in. I know.
So when you say that, what you're saying is like you're creating a driver, it exercises the interfaces. It doesn't really have a device involved, but you're, twiddling the bits that a driver would twiddle. It sounds like what you're trying to have these
right,
do?
like it's all the PCI core infrastructure. Like, hey, can we set up and tear down IDE streams and allocate things? Can we mark MMIO as encrypted in the resource tree and make sure that at least on x86 does IR remap do the right thing? Those kind of tests that don't actually need. It's basically unit tests.
That makes sense.
On the ARM side, I actually use FEP. So it's not actual device, though. It's still kind of like emulated kind of a thing. But then, yeah, the latest changes have not been tested because I'm waiting for a firmware update with the new spec update. but the one I posted last time has been we are able to kind of get the full realm secure device mounted like a disk, right? It actually model an HCI disk, and then I could mount it, do secure DMA, everything with whatever TSM framework we have and the CCA callback.
Well, you said
So,
with which particular? You said FEP or something?
yeah,
sorry.
FEP. This is the model that have which kind of model different hardware platforms.
I see.
Foundational platform, I guess. If I'm not sure about the full, I don't know.
What the other letter is, yeah. Is this a thing that's available publicly, or is this just purely a thing that's built on top of internal stuff for ARM?
Fixed virtual platform. I think there is a version which people can download externally, but it's also the platform that vendors use for bring up before the boards or before the CPUs are really available.
That makes sense.
So yeah, so it kind of gets all the details correct. So it has got the root port kind of thing and endpoint with all the details under emulation in FEP. So it still is not completely accurate. So as in like, if I am doing stream ID programming wrong, will the model catch it? Maybe, maybe not. So that's something getting improved on the model side to be as accurate as possible for TD spec. But at least it will catch a lot of things and I'm able to get it all done.
Yeah, that makes sense. Cool. Thank you.
And then no, TDEC side, it's a internal FPGA test card. It's not a real thing. I know Alexi's been talked about his device, but I'm not sure how real it is or not. But we did go through this exercise on this and workaround we're putting in the core. And I'm not sure how many actual endpoint devices are going to do this in real world, but it seemed like he was saying that he thinks it's going to be a thing, and I think I can see how it would be because it simplifies the device. But he has a device that when you go to start an IDE stream, if any of the basically the hardware picks which resources to enable based on the stream ID, and so that's you're transitioning a stream ID from kind of idle to secure or turning it on. The hardware gets confused if you have multiple potential stream resources with the same ID, which is basically what the device does at a reset. At a reset, all the stream ID register values are 0, and so what this you call it a quirk, or maybe the feature of Linux is Linux is basically going to go through and pick a stream ID, probably 255, and set that to be the default stream ID for idle streams, and that makes sure that the ones that you're actually programming that are in the from 0 to 254 are never match that one. And so, not sure if that's going to be an interesting thing or it's like a spec gap, but it seems reasonable, and so that's the quirk we have for that device. But yeah, but otherwise, yeah. This is also the point of the staging tree is not everybody has access to everybody else's test environments, and so we could maybe track some of that stuff in the maturity map, but I think the easiest way to do it is that a 3 means that people have reviewed it and acted, and you probably shouldn't act and review it unless you've tested it at least to your own local ability, and I've gotten thumbs up by from so far from people. But yeah, speak now if that's not true, and actually in the or something's broken. But as far as I know, like AMD, Intel, ARM have all played with this, and it's working.
That makes sense. Mostly my thing is that I have to also, when I start bringing up other people's kind of intermediate code, I have to ensure that our own environment is working, and I'll have two things that could potentially be, or several things could be going wrong. and that's always a little bit of a exciting element of trying to do bring up. So
that is also part of why, I mean, at least for the sample driver, I did it for other bring up of like CXL PMM, these other kind of things. Is like when you're bringing up the hardware and you don't know which way is up, it's nice to know that, okay, at least at least let's get a test pass, and you can focus more on what the actual hardware is messing up on, or what the driver got wrong about the hardware, wrong assumptions.
Yep.
But yeah, totally there with you. But any other questions about maturity map? How to, or what are some of the topics in there? Yeah, the biggest one for phase one is just getting this from a zero, getting this off of zero and getting some stuff integrated in the tree. But yeah, I'll push out those finalized patches, the address association, and off we go.
So Dan, for the staging, from the architecture point of view, do you want the full patch set branch or only the IDE setup branch?
I want to keep it. Yeah, I think for now let's just do just the IDE branch.
Okay, I'll get that done.
And yeah, go from there. Because yeah, because I mean, like especially for what's going to go into Linux next. But yeah, but ARM is not going to be there for 619. I guess I haven't. So I've been so focused on this staging and stuff. Like, I don't know. You and Loon tell me, like, is the it sounds like we're the work in progress patches for DMA buff and VFIO are agreed upon. Like it's not like we currently have a situation where CCA wants to go this way, TDX wants to go that way, and TIO wants to go the third way.
That's
right?
one of the reason I was wondering whether the staging should take the full patch set so that at least we can compare the implementation across different architecture. Because I'm not sure we are pushing staging to next or anything. We are just want staging as an integration point where we can see each other's patches.
Yeah, just integration point. So, yeah, as long as you have a stopping point where I could say, like, if I drop everything else past this point, this is phase one, then you can.
So I will do two topics branch then, like,
okay.
Topics CCA full and topics CCA IDE setup, right?
Okay. Yeah. Like I can tell the difference, then I can pull in and be like, this is
because having the full tree is good, because I do have this VFIO DMA buff I haven't pulled in, because for good path DMA buff, I'm not using DMA buff. DMA buff mostly gets driven when the VFIO is trying to do something and we want to make sure that the things get unmapped correctly and things like that. So I did have DMA buff in my tree, but since the patch set itself is not being looked at or pushed by me, so I kind of dropped it because I'm not calling into DMA buff directly. I expect other subsystems to call DMA buff, and then the DMA buff handler will come back to the architecture specific thing, right? I do have dependencies on few things. One is the KVM CCA changes, which is still not upstream. And then there is a KVM pre-fault IOCTL, which I'm using to fill in pages for pinning DMA memory on the secure side. But then we can see all these things once I have the full tree there, so that it's much easier to follow. Right?
Is that stuff in? I guess, is there a cave? It's not even in, like, it's not, since you're not still working on the spec. It's not like that stuff is in the KVM staging branch, or not, or the KVM.
No, the KVM CCA changes are not in the next, because as I mentioned, the spec is kind of going an update. We did post it multiple times, but it is not in next, or it is there is a reviewer feedback based on that. The things are being reworked. But for the operation of DA, I need something from that KVM patch set, which is basically handing over certain pages to the firmware, so that firmware have enough memory to operate on the DA operations and things like that. So we call it granule delegation. So I'm using granule delegation, which is kind of implemented by the KVM patches posted, right? KVM CCA backend patches posted. So I'm carrying that tree. So that's just so that there is one place where one can get everything. One of the thing I have done is in my trees, I have created all of them as topic branches and then merges into the final tree. So one would know like what is the DA bits and what is getting merged. So there is merge commits in between, which is showing the flow nicely. Yeah.
Okay. Yeah. Okay. Yeah, because we're almost in a similar situation, but thankfully, like the TDX base series is upstream, but yeah, we're still gonna have like a delta, a plus delta, especially for things like this VMX on rework that are only gonna live in the staging tree until they finally make it into the KVM tree. I was going to start pulling Paolo's tree if some of these TSM drivers had dependencies on it, but I think so far it's either stuff that it hasn't gone to that tree or is not a candidate. So
It's not even in Paolo's tree, it's getting reworked. So yeah,
okay.
So that's why I'm carrying all of them in my branch. Yeah.
Okay. Yeah. I will not touch anything besides git merge. So make sure like I mean but actually if there are conflicts with our stuff like that, that's the interesting stuff. That's where we're like, oh, why'd you touch that? And so we'll see. I think you'll probably get 0-day reports from it. We should be getting compile.
Yeah, that would be nice. Yeah.
Compile testing on it. I think we've been through 8 versions of the core pieces. They've been on the list. They've been on this tsm.git branch. I've gotten multiple like 0-day build success warnings, but with the way that 0-day works is it actually does rand configs over time, and so as soon as I push it to Linux Next after months of this stuff being in production, 0-day is like, oh, I did find a rand config with Spark, and you're like, dang it, dang it, 0-day. But so I'll see if I might just fix it up incrementally, just to give the commits more soak time, and we'll go from there. Okay. Any other opens or concerns?
I mean, if we have time, I always have more questions to ask that I don't know if other people are interested in, but I will ask anyway if we have time.
Yeah.
Peter may have asked this a few weeks ago, so you can also tell me to go watch the previous time as well. But what's the intention with the netlink socket for attestation? Like, is this just the going to be the interface for communicating up instead of SysFS or something similar, or what's the intention there? I know there was some history of many back and forths on the precise interface or the intended interface, but
the history there was Lucas built a SysFS interface, a very dynamic and capable SysFS interface, and then was demonstrating it at the Bird of a Feather session at Plumbers, and showing like kind of these complex of, okay, to get this nonce in there and this format over this, you have to pipe this to OpenSSL, then you have to cat this over to this thing, and it was basically at some point the audience kind of said like, this is way too much optionality and transactions for SysFS. I think a better interface would be netlink. Netlink can do kind of that, more of that back and forth. But then since then, Alexei still has his stuff in SysFS. I think the TSM case is maybe not as complicated in terms. We especially don't need to install certification into the kernel. We're just basically getting blobs in and out. So I think it could be simpler. And and kind of Peter's like, oh, so like what needs to happen there? It's like, well, it really just needs somebody to just start the discussion to say like, oh yeah, hey, we saw the Lucas BOF thing, and we're gonna do this whole full netlink thing, or no, we're gonna go this other direction with TSM, and these things might end up just being separate, the native CMA versus the TSM authentication path, and just flesh out those conversations with like those same parties that had an opinion, like get them to look at at TSM specifically and see like, okay, do you still have the same gripes? And so
because I think it was Jason Gunthorpe that was interested last time and was pushing back quite a bit.
I think Jason Gunthorpe did it. I think James Bottomley was also like, yeah, that's probably a good idea. And the Hannes, right? Hannes also said, yeah, no, we do certificates and other things for SCSI and in Netlink, and so that's where that got legs. But
makes sense.
But yeah, in terms of, am I convinced that's the right way? I just know that the community has questions, and usually got to answer them somehow. Be like,
yeah, exactly. Like pushing the complexity into Sisyphus might feel inappropriate, but it's not necessarily the case that Netlink is the only option, or even if there's a different way to work around it. But that makes sense.
Just pick an ABI, defend it, and get everybody to come to consensus.
I think the get measurements was the one, right? I mean, it actually have options to specify the nonce and also whether you need a full transcript signed, right, or non-signed. I think this is the combination which made it complex. How do I specify all the combination of this so that the verifier can request a measurement block the way it wants?
And it's even more complex than that, right? Because you can do some frankly silly things with get measurements on SPDM. Like, for example, pull each index unsigned except for the last one, then pull that signed, right? And the current TSM interface that I see doesn't really allow for something like that. It doesn't actually allow you to do the actual SPDM get measurement calls. It's expecting you to get some sort of device report back. And the reality is, you probably should, even if it's the TSM's mediated get measurement requests, you need to be able to provide that to the guest, because the TDIS spec is expecting the guest to be able to do whatever it wants with SPDM measurement requests.
Yeah.
Not to mention the fact that there's other weird things that you need. Like, for example, like you kind of need to know what the response of the algorithm's request was. And the only way you're going to get that from the TSM is if they hand you the whole transcript, right? Because you have the VCA as part of the transcript. So you kind of need these things exposed via the TSM's interface for measurements. Otherwise, you can get an index back and you just know it's a digest and have no idea what the algorithm is because you never got your hands on the algorithm's response.
And I think Lucas is basically, SPDM gives you so much optionality and freedom. Let me make sure I reflect that in the ABI. And I don't think you're right. I don't think we might not even be able to even get access to the same level of degrees of freedom.
Yeah, but one thing I want to make sure, like I think the expectation is that all the measurement blocks are not going to be fetched because that's going to be pretty huge. So the verifier is going to request for like a specific measurement blocks and most probably signed with full transcript. And with respect to CCA, there is an interface which can specify which blocks are being requested, and it can indeed do the SPDM such that the first block, second blocks comes unsigned, and the last blocks have the signature, which include all the right. So we do need to prevent any other DOE or any other SPDM request coming in until we finish that, and we do that by serializing at the device communication layer on at least on ARM. That's what I have implemented. So what you've mentioned as it do support non-signed few blocks and the signed last block. I thought that's the normal flow of operations, right? Is that not the case?
From what we've gone through in our discussions on the device side, I can't speak about the host side, but just for that reason that you specified alone, the race condition between any other SPDM operation on that device and the series of get measurement requests that you have to do, it seems like it's more reasonable to just get everything, right? Because the amount of data that you're going to get back from, even assuming that you use all 255 Sorry, 255 minus whatever the 4 or 5 reserved indexes are, and you still have a sizable manifest. It's not going to be that huge data wise, unless. So to be fair, the firmware. So when you get a firmware measurement in SPDM, you have the option of pulling the firmware back. You could say, give me the raw bytes of it or give me the digest. I can't imagine anyone's ever going to give you the raw bytes of the firmware back as part of the measurement. It seems silly to do that. I don't understand why it's even in the spec to begin. Just having a digest of it seems more than adequate. And if you need to really get bytes for that firmware, your TVM can go out and pull that firmware. If your TVM probably has that firmware at that point, because it was most likely the one that loaded it into the device. So, like, it seems overkill to return the raw bytes of a firmware in an SPDM measurement. So you're most likely just going to be handing back, SVNs, version numbers, hashes, a structured debug state, and maybe if you want to get really robust, a commid, maybe not commid. I forget the exact spec that's used in the manifest field, but like that encoded manifest of what each of your fields, each of your indexes represent in your measurement. That's the FE measurement index. You can get that back and say, okay, index 1 is going to be this module ID OIG, and it's going to be the version for that module OIG, stuff like that. So you can do stuff like that with it. But even then, it's not going to be huge. We're not talking about megabytes of data, right? We're talking about much.
Yeah, I'm hoping and that that matches my hope in terms of like the simplicity of this interface to make it. I mean, if you think they were going to need that niche, I would like to maybe challenge that. Like if we can start with, hey, your only option is everything, and then see who screams, and if nobody screams, or if we can support that.
Okay, yeah. So at least at the CCA TSM layer, I have made it generic, and I think whether it is SFS or Netlink, what it exposes to request probably will control that. But at the interface layer, we do have the ability to request for a specific block. And the way I prevent a parallel SPDM call is there is this ordered work queue, which kind of takes only one task at a time, and then others will wait until we finish all the measurement request or any request which I get for device communication. Yeah, so
is that the DOE work queue request or actually?
No. There is another work queue which is
RTSM
specific, where we kind of have a much higher abstraction of this RHI request, realm host interface request, because of this problem wherein a measurement request cannot take another SPDM request while the last block is pending, right? The one that David just mentioned.
Yeah, I think at TDX we have a message exchange, but like it might be multiple DOE messages, but Elun, right? Like we have a lock over the entire kind of message exchange request, and if the module wants us to do multiple messages, it basically says, hey, just make sure that nobody else is running this at the same time.
Yes.
Am I?
Yeah.
Okay.
Yes.
Okay.
Oh, cool. Yeah. So, I did hear from Alexi that at least for x86 tip tree, like the normal Boris path, but I think Boris is okay to ACK the bits going in through this tree, and Bjorn ACKed it. So this wasn't my plan to be the upstream merge path for AMD, but it looks like it might be that might happen. I don't know if it's same on your side, Anish. Like, are the do you think the ARM maintainer is going to take your stuff?
I can come back on that, which tree is preferred. I think, considering we have been looking at the patches and discussing this, maybe your tree is also good. But then I don't know what the preferences are from ARM maintenance point of view, right? I can check with them and then understand.
It's no skin off my back to do it if you want so yeah, if you need that, if you want to go through TSM deck, just let me know. I
Yeah,
don't think
sure. Yeah,
it'll be a problem.
definitely. Yeah.
And for TDX, I haven't got the confirmation from Dave if he wants to take it or not. I'm assuming that he'd probably be like Boris and be like, no, I'll just hack it. And off we go. Cool. Yeah. Any other questions opens before we wrap up tonight? If not, oh, did will that work for you, Anish, to just set the TDI yourself locally? I think it's okay.
I'm sorry, I didn't get that.
You'd asked about, hey, can the PCI TSM TDI constructor set the
So
TDI?
so as I said, I am not able to test my changes yet because I'm depending on a new firmware and I can't go back
Okay.
to the older version of the firmware because the interface has changed. So yeah, but looks like it will work. I was just wondering whether it should be generic because other ARCs also have similar requirement. But anyway, I would let you know. Yeah, I mean.
Yeah.
But right
Yeah,
now I have made the changes you suggested.
Okay. Yeah, as long as that works. I think I'm still it tries not to be a mid layer. So yeah, it should be the case that if something that the core does is not quite right, you have the this is just a library and do the right ordering and what you want to do in your TSM driver. But we did for like TDX actually needed some of the register settings that PCI calculates. It doesn't actually want the core to do the root port register writes. It actually wants to pass those to the TDX module. So we refactored one of the for the address association. Those got factored out, and TDX can use that. But yeah, if ARM needs something similar, like if there's pieces of the core, yeah, let me know. We can factor that out. But, okay. Well, yeah. Thanks for all the review and hey, I think we're making progress here.
Thanks all.
Thanks everyone. Yeah,
Cool.
We'll see you all next one.
Thank you.
Thanks.
Okay, bye.
Yep. Have a good day.